What if I told you the Earth built a working nuclear reactor billions of years before humans even existed? In 1972, French scientists analyzing uranium ore from a mine in Gabon, West Africa, noticed something weird. The uranium was less radioactive than expected. At first, they thought it was a mistake. But what they uncovered was far more bizarre. Turns out, nature didn't just store uranium underground, it used it. Deep beneath the surface, in a place called Oklo, the Earth triggered a nuclear chain reaction. Not an explosion, not a disaster, but a stable, self-regulating nuclear reactor that ran for over 100,000 years. No wires, no engineers, no concrete domes, just water, rock, uranium, and time. This wasn't a freak accident. It was a naturally occurring nuclear power plant built by the planet itself 2 billion years ago. And the most mind-blowing part? It operated more safely than some reactors we've built in the 21st century. This is one of the strangest, most awe-inspiring discoveries in science. And it's 100% real. You're about to find out how the Earth pulled off a technological miracle. Long before technology even existed. Setting the stage, a nuclear reactor? So, what even is a nuclear reactor? Let's break it down. A nuclear reactor is a machine that takes something invisible, atomic energy, and turns it into heat, light, or electricity. But not by burning anything. It works by splitting atoms, specifically uranium atoms. Inside a reactor, uranium-235 nuclei absorb neutrons, split apart, and release a burst of energy, plus more neutrons. Those neutrons hit other atoms, and boom, a chain reaction. But here's the twist. Chain reactions can be wildly unstable. That's why reactors use special tools to control them. Moderators, coolants, and control rods to keep everything from overheating or going full meltdown. It's one of the most complex systems humans have ever built. And yet, Earth did it first. Without blueprints, without scientists, without even meaning to. The Oklo site in Gabon had just the right uranium levels, groundwater to moderate reactions, and rock formations to contain the heat. It didn't need steel. It didn't need power lines. Just physics, geology, and 2 billion years of patience. This is where science meets sci-fi, and it actually happened. Let's dig deeper. The real story starts with a missing fraction of uranium, and a question that nearly broke physics. Discovery. The day physics broke the rules. In 1972, scientists at a nuclear processing plant in France were testing uranium ore imported from Gabon. Simple routine, right? But then, someone noticed something that should have been impossible. The uranium-235 levels were too low. Not dangerously low, unnaturally low. See, uranium-235 is the stuff that actually makes reactors work. And no matter where you dig on Earth, it always makes up about 0.72% of natural uranium. But this batch? Only 0.60%. That may not sound like a big deal, but to nuclear scientists, it was a full-blown red alert. Why? Because the only way that percentage could drop is if someone or something had already used it for nuclear fission. Cue the freak out. Did someone secretly run a reactor in Gabon? Was it a mistake? A hoax? Or was there something happening inside the Earth that no one had ever imagined? Turns out, deep underground, something had burned through the uranium, not in a lab, but inside ancient rock. That missing uranium wasn't gone. It had been spent as fuel. And just like that, physics had to face a wild truth. Nature had beat us to nuclear power by 2 billion years. The impossible explained how the natural reactor worked. So how did a nuclear reactor, like an actual functioning fission machine, just casually exist underground without human help. Let's break down the brain snagger of the century. Step 1. Go back 2 billion years. At that time, natural uranium contained way more U-235, the rare isotope that's fission-friendly, around 3%. That's just enough to sustain a chain reaction. Coincidence? Maybe, but it gets weirder. Step 2. The rock formations at Oklo had the perfect concentration of uranium ore in tight, compact zones. Step 3. Groundwater flowed through the rock. Water acts as a moderator, slowing neutrons just enough to keep the chain reaction going, like a nuclear dimmer switch. And here's the kicker. When the reactor got too hot, the water boiled off, reaction slowed down, everything cooled. Then, water came back, reaction restarted. Repeat. It was self-regulating, a natural on-off switch built into the Earth itself. No meltdown, no engineers, no power grid. Just physics doing its thing, like nature had a blueprint for nuclear power before we even invented electricity. It didn't explode, it pulsed. It didn't fail. It ran for hundreds of thousands of years. That's not just incredible, that's alien-level elegant. And Earth pulled it off all by itself. Deeper twist. This reactor was safe. Here's where things get even more unbelievable. This ancient nuclear reactor, it wasn't just real, it was shockingly safe. Let that sink in. No meltdowns, no radioactive leaks, no catastrophic failures. Just a natural underground reactor quietly running and shutting itself off when things got too hot. Compare that to us. Human-built reactors need thick concrete shields, active cooling systems, emergency shutdown protocols, and we still worry about accidents like Chernobyl and Fukushima. But Oklo? It ran clean. The fission byproducts, radioactive waste, didn't escape. They stayed locked in the rock for over 2 billion years. That's not just impressive, that's geological-level containment. Scientists have studied it to understand how to safely store nuclear waste today. Yup, we're taking lessons from a prehistoric power plant. And guess what? Nature nailed what we still struggle to master. Stable chain reactions, automatic shutdown, long-term storage. This wasn't a nuclear accident. This was a nuclear masterpiece. It's almost like Earth left us a note that says, yes, it can be done. Here's how. Coming up next, what this means for the future of energy and how this ancient secret is still changing science today. Science implications. What this tells us about the universe. Oklo isn't just a weird story about some glowing rocks underground. It's a scientific reality check and a cosmic clue. Because if nature can build a nuclear reactor without any help from us, what else is it doing out there? First, it rewrites what's natural. We used to think nuclear fission was purely man-made. Turns out, the Earth was splitting atoms before we stood upright. That's not just wild, that's humbling. Second, what if it's not just Earth? If uranium, water, and just the right temperature can spark a reactor, then what about other planets? What about Mars? Europa? Exoplanets we haven't even found yet? If Earth did it, maybe other worlds did too. Now imagine a natural reactor shaping an alien environment, heating a subsurface ocean, maybe even affecting the evolution of life. Oklo shows us that fission isn't fiction, it's physics, and physics works everywhere. This single discovery cracks open the door to a bigger idea. Maybe intelligent energy systems aren't uniquely human. Maybe the universe has been running experiments long before we arrive to notice. And Earth? Just one of the lucky test sites. Stick around. The final twist is even stranger. The legacy, Oklo's lessons for future energy. Here's the wild part. This isn't just a cool fossil from Earth's nuclear past. Oklo might actually be a blueprint for our energy future. Because when scientists studied the Oklo reactors, they didn't just find natural fission, they found solutions. How to store nuclear waste for millions of years. How to design fail-safe systems that shut themselves off. And how to build reactors that don't need constant human babysitting. Sound familiar? That's exactly what next-gen nuclear energy is trying to do. Small modular reactors, passive cooling, long-term stability, all things nature casually pulled off 2 billion years ago. Some researchers even believe we could build modern reactors in stable geological formations, just like Oklo. Nature didn't need steel, wires, or control rooms. It just used the laws of physics and a really patient timeline. And here's the kicker. Oklo's uranium fingerprints have even helped test the constants of physics over deep time. As in, has the speed of light changed? Short answer, nope. Thanks, Oklo. This isn't just a fossilized power plant. It's proof that energy, when done right, can be safe, stable, and self-sustaining. And if we listen to the rock, we might finally stop reinventing the wheel and start learning from the planet that built it first. So, what did we just learn? The Earth, yes, our Earth, ran a nuclear reactor 2 billion years ago. No engineers, no blueprints, no warning signs. Just uranium, water, rock, and physics playing its long game. It wasn't an accident. It was a naturally occurring nuclear system that cycled on and off safely for hundreds of thousands of years. And buried in the heart of Gabon, it left behind the radioactive fossil of something we thought only humans could build. We think of nature as forests, storms, oceans. But sometimes, nature builds power plants. And maybe, just maybe, we're not the first to harness the atom. We're just the first to realize the planet already showed us how. This is the kind of truth that doesn't just change science. It rewires your sense of reality. If nature can build a reactor, what else is it building that we haven't noticed? This is BrainSnag, where the weirdest things turn out to be real. Smash that subscribe, because your brain deserves a little more strange, and we're just getting started.